continue to have some ideas on what we can do. Okie dokie. Let's keep on trucking here from current slide. Okay, can everybody still see my screen? We were talking about asking a research question. Did it load?
Yep.
Okay. So we were just at the point where we're discussing the importance of asking an empirical kind of question when we want to have actual empirical research, right? Two kind of go together. And that the question of are women paid less than men for the same type of work is an empirical question because we can measure it, compare it, and come up with some sort of result and interpretation about it. What would not be an empirical question would be, is racial equality good for society? Because inherently within that question, we are inserting some sort of value, some sort of bias, some sort of subjective preference that cannot be independently verified. We may all agree that that would be a good thing, but unless we can actually like break down what is good, and like I wrote on there, we need to operationalize it. We need to quantify it. We need to find a way to measure what does good mean. So for instance, if I said good and I meant that means there will be greater economic growth, oh, perfect empirical question, right? Because that's something we can measure. Or decrease in crime, right? Or if I was providing all of my participants some sort of questionnaire that measured like mental well-being, right? Like our well adjustment, our emotional satisfaction, our life satisfaction. And then I saw that with equality, there was a greater life satisfaction, right? Like there's a way to then measure that. If we can measure it, observe it, and replicate it, that's what's considered a good empirical question and part of the empirical process. So again, if your mind, and again, there's some folks who are just designed that way where they're thinking more in qualitative terms, like, what is this like? And is it good? And more philosophically based question. We just need to get to a point where we can define the word or the value in a way that is that we can put numbers to it and we can measure it, and someone else could do the same thing and come to the same conclusion. Does that kind of make sense? So I want to make sure that the takeaway here is not that asking a non-empirical question is not a good thing. That is still very much a good thing. But if we are going to utilize statistics and go through an empirical research process, it needs to be measurable in some way. There's just no other way around it. Okay, so there's other questions here that you can look at. So again, I like this one. Is there a critical period for learning statistics? Because oftentimes people will talk about that, like critical period in terms of learning language. That's probably something you guys are familiar with, right? If you're not exposed to language at a young age, like right around 1 to 2 years old, you won't develop the ability to describe phonemes and make the sounds with your mouth so that you can actually be a fluent speaker later on in life. They've done that research on folks, small children, often small villages that were raised by parents who were either deaf or mute, and so they just didn't have the exposure. And so if you're exposed to it later in life, you're just not able, right? There's that critical period. You're not able to match. So this is kind of a joke, right? So no, there is no critical period. You guys can all do it. Don't be scared. All right. What is the role of theory and why do we care about that? Well, it's pretty huge, right? A theory is a set of assumptions or propositions that social scientists or you and I or the world at large that we use to explain, predict, and understand a specific type of phenomenon that humans can produce, right? So what is our role in that? And so under that umbrella is the theory. So right, like you observe something, you see something, and you want to explain it away, and it kind of fits in a particular theory pattern. So what do we mean when we're saying about a phenomenon? Well, it's usually some sort of behavioral set, right? Like something that occurs, something that is uniquely human that we can see. So we use then the theory to attempt to establish that link between what we observe, what we're seeing, this data or this phenomena, and our understanding of why this happens and how they're related in a particular way. So the question here that I had posed earlier, are women paid less than men for the same type of work, right? So that's the question. It goes back to a higher level question, which is there a gender segregation theory? So that somehow, there's gender bias or that there's unfair treatment because of gender roles, right? So that's the theory that it feeds back to. So if I was doing a research study, right, I would start by describing all of the theory that explains away my line of thinking, all the way up to my hypothesis, right? Almost like telling a story. So you're setting the stage with all past theories and past studies that have been done to then get to your hypothesis that is justified and supported by past theory, right? Because you're not going to come up with a hypothesis out of thin air. You want it to kind of make sense and it be based and rooted in something. And then you describe your research question and how you're going to go about measuring it, and that goes into methodology. So the role of theory is pretty crucial. Now, theory is up high, and I've used this word a lot. Hypothesis kind of goes below, right? So you've got the theory, the research question, and your hypothesis. The hypothesis is a statement that's generated by that theory, or possibly even a previous observation, that predicts a relationship between two or more observational or observable attributes or variables, okay? So it is what you suspect will happen. So when we did the example last week and we talked about numbers of pairs of shoes, excuse me, our hypothesis could be women have more shoes than men, right? Like you come up with that, and maybe that's based on a past observation of yours, right? So, or perhaps you've read studies about, I'm making stuff up now, but read a study that women have more material objects than men. Just made that up. Don't think that's necessarily true, but let's say you did, right? So that would then inform your hypothesis. And that hypothesis, that statement that you make, predicting what you think the relationship will be, that is something that can be empirically verified, right? That another researcher could be like, huh, okay, so you think that. Huh, okay, interesting idea. Let me run my own study and I can verify whether that statement is true, right? Okay. So the statement of that relationship between specific characteristics can also vary, right? Those are variables. So I can go into this. So for instance, if my research question is, are women paid less than men for the same type of work? That is supported by the gender segregation theory. That's the overarching theory that kind of pushes this research question to the forefront. My hypothesis could be occupations that are majority female pay lower wages than occupations that are majority male. Okay, so I just went a step further and defined that. Now, what do we need to do? We need to look at what is actually like the job that would be majority female and what would be a job that's majority male. So I would need to do some sort of observational study to also look at that, right? So one of the examples I wrote on there is preschool and kindergarten teachers tend to be 98% female. So those would be two occupations that are predominantly female-based, right? They're saturating the workplace. CEOs, on the other hand, are 95% male. So that would be another one that's kind of saturated by males. So now if I take the average on both sides, right? Kindergarten and first grade teacher or preschool teachers, take their salaries, create a mean, and then take a salary and create a mean of male CEOs, and now I compare it, that can then confirm or refute my hypothesis in regards to pay, that occupations that are mostly females pay less than occupations that are mostly male. Okay, is that making sense?
Can I ask a quick question?
Yeah, of course.
So it doesn't have to be both men and women CEOs or both men and women kindergarten teachers?
So that would be a slightly different question or a slightly different hypothesis. So here the hypothesis is occupations that are majority female pay lower than occupations that are majority male. What I could do though would be so occupations that are varied, women will still make less money than men. And so then I would pick one specific occupation that is more evenly distributed, right? What would that be?
Okay, so does that mean like the research question, are women paid less than men for the same type of work? That doesn't have to do with that hypothesis at all?
So go back again, something with the racial question?
The research question, like above that, is are women paid less than men for the same type of work? So is the hypothesis like, that's not relating to that research question, right?
It is. So the research question is kind of a more overarching wondering. I am wondering if women are paying less are paid less than men. Now, in this particular subset hypothesis, I split up the occupation. So the same type of work is not quite as focused on. The gender segregation theory would still support that. What would maybe be closer to that research question would be if I pick accounting, for instance, or somebody else said healthcare, I think is what I heard. So then I could look at, a physician, a GP, and what is the average salary for a male and a female that have been in the job for a similar amount of time and see if there's a significant difference. So there's multiple ways to go about it. Does that kind of make sense?
Yeah.
Okay. So again, your research question can be real broad and like, it's more, I like to say it's more of a wondering, like, I wonder about that. And then you feed it into the theory, and then you feed it into your hypothesis. Like, what is it I'm actually predicting is the relationship? And then you find a way to measure that to confirm or refute. Little note, you never prove a hypothesis, right? There, in the social sciences, there is no linear one-to-one direct causal relationship. That's not how it works in social sciences. So we can confirm or refute, or, those are the kind of language that we'll use in regards to the hypothesis. Make sense?
Yep.
Okay, let me move this right here. Okay, so what is a variable? It's the property of people or objects that take on 2 or more values. And why is it 2 or more values? Because we need a way to measure it. And if it's just, it is, right, the presence of a trait, there's less measurement, and you can't do statistics with that. So it needs to be more than one value for it. So it needs to include categories that are both exhaustive and mutually exclusive. So if I have a variable where there's overlap, that's going to make it very difficult to actually measure if somebody is in 2 categories. So the categories need to be mutually exclusive. So for instance, gender. Well, that's kind of a tricky one. We can do multiple gender, right? It could be more than binary, but usually one wouldn't fit in more than one category. Political affiliation, again, we could get more than one category into that. It wouldn't just be, are you political? Yes, no. I guess that would be binary too. We could do that. But usually you're dividing it into more subcategory. Social class, what are the kind of categories that we hear for that you guys are familiar with?
Poverty.
Right, so what, if we're thinking about social class, what do you hear that's related to that? Because yeah, you're right, with poverty, what would we classify that?
Like working class.
Right, so we'd have middle class, working class, upper class, right? Like all those, that's how we would divide social class that way. So that would be a variable that can be measured. We'd have to quantify what that looks like, right? Because we may have a different definition of that. But within that variable, there's multiple categories. Okay, so here's just that. So lower, working, middle, or upper class, again, with this, with gender, this one is just a binary one. We have multiple categories now that we could add. Same with education, right? You can use some of that as well. And you just write like, what's your highest level of education? So they'd select one. Okay. This is gonna be hard to do on Zoom. Okay. We're gonna skip the group work, you guys. These are all the fun things we can't do. Okay. It's all right. It's all right. Make it just as good. All right, units of analysis. How do we actually measure these things? So the level, here are the levels that we focus on. As social scientists, this is what we're interested in to do. Like, we want to look at the unit of analysis. So if I'm looking at individuals, how do I measure individuals? So maybe I'm measuring their age. Maybe I'm measuring a score on a test that they completed. So for instance, a facial recognition test. Maybe I'm interested in their occupation or their highest level of education. Maybe I'm interested in their religious affiliation, whether they're the marital status, right? These are often clumped together as demographics. So the larger concept of how can we measure things that are particular to that individual. How do I measure families? So maybe I want to know about the number of children or the count within that family unit, how many adults there are the parents actually married, not married, divorced, right? Like all of those things. How do I measure organization? So If I'm a university, for instance, maybe I want to talk about the diversity that's on campus. Maybe I want to talk about continuing education. Maybe I want to know how many types of clubs there are, how many different athletic departments there are, like different sports that are affiliated, different degrees or academic departments. So those are other ways we can measure organizations, such as universities. When I measure cities or townships, right, I can look at crime rates, I can look at population density, diversity, mobility, right? Are folks able to move in and out of those areas? And then social artifacts, just more broadly. You can look at children's toys as a function of gender, clothing as it relates to, like, there's social artifacts that you can measure by looking at specific variables and how they relate with a higher up idea. So those are considered units of analysis. So this is what it would look like, right? So you could ask the question, how old are you? What are your political views? What's your occupation? And then within that, you are classifying individuals. Families as a whole. Families as a whole, you're looking at the entire family and seeing how that impacts it. So how many wage earners there might be. You might be looking also who does the housework, right? Like talking about specific gender roles within that as well. Looks like, oh yeah. And then if you're looking at organizations, you can look again, our number of employees, is there a diversity office? What's the gender composition? And then again, looking at a city, we talked about crime rates, all that. So this is different ways of measuring based on what is your question, right? Now in the social sciences, mostly we'll be focused on individuals, sometimes family, and then again, more rarely we'll look at organizations and cities. Now for our class, it'll be almost entirely individuals. Oops. Uh-oh, that's not good. Can you guys still hear me?
Yes.
Okay.
Yep.
But my PowerPoint. Okay. Can everybody see cause and effect?
Yep. Yep.
Okay, super duper. It wasn't moving for some reason. Okay, so there's 3 criteria we want to look at. Now again, we want to be cautious with that. So if we're looking at finding like any sense of causality, we need to look at the order of events. The cause has to precede the effect in time. So that would be temporal precedence. So within a given amount of time, something needs to have occurred previous. For instance, if I am doing a pre-test, and then I'm teaching a class and I'm doing a post-test, well, in order for me to see if people have learned, I need to have had temporal precedence. There needs to be a pre-test to determine whether there was actual growth, right? Otherwise, I'm just measuring an end result, which may have nothing to do with the course, right? As we talked about last time. There needs to also be an empirical relationship between the cause and the effect, and that's often called covariance or some sort of correlation. So they relate to one another in some way that as one variable may increase, it'll impact the other variable in some other way. So the more potato chips I eat, the more one goes up, the more my weight goes up. Look at that, right? So, okay, increase in potato chips, increase in weight. The more I study, the higher my grade, right? These 2 variables have a relationship and they co-vary, meaning they change at a similar rate. The last piece is that the relationship cannot be explained by other factors. So that I have eliminated other options, that I'm truly just looking at a pure relationship between 2 specific variables, and that's called internal validity. Again, potato chip increase, there are some people whose weight is not going to increase. Maybe they have super fast metabolism, don't like you. Maybe they are an athlete, right? Who can eat all the potato chips in the world because they are working out a ton, right? Like there's other variables that could explain away the relationship, especially if the relationship is not behaving in a way that you predicted. That means another variable is at play. So, yeah, so I want to be very careful when we talk about cause and effect. I've said this before, because again, the social sciences are not in the business of being like a perfect predictive model. That's just not, we don't do that well. You do need experimentation and some sort of research process in order to evaluate any claim that you state has a causal relationship. And that tends to be done more in the medical sciences, where the introduction of a drug, for instance, has a direct effect on the individual. So, right, psychopharmacology could be that. If you have a blood pressure problem, you introduce a medication. Do you see what I mean? Like, there's a direct impact. With social sciences, it's a little harder to parse out any other variable because it is so linked together. Even my study example, right? Maybe you studied for 6 hours before that test, but the test was a terrible test, right? Like the professor didn't prepare you for it at all and asked you questions that were unreasonable. Or maybe you studied a ton and then didn't sleep at all. And the insert variable that impacted your test score was the fact that you were like delirious because you hadn't slept, right? So there's other factors that play a role. So to say that the variable of study is the only variable that impacts or the only cause to the effect of your grade would be inaccurate. So we need to try to get as broad of a picture. And that's why in statistics, when we do inferential statistics, we'll talk about that in a minute, as we are inferring what A led to B, right? So what variable then led to the effect of what we observed? And we want to see which of those variables had the greatest impact, which one accounted for the most variance. That'll be another word we'll use out of all those things. So example time. If you are looking at you're looking to see college success, right? What leads to college success? Perhaps I'm interested in finding out about how well you did on the SATs. Or do you guys take the ACTs now? What do people do? SAT? Okay, well, whatever standardized test, right? So you took a standardized test. Is that going to be predictive of how well you do in college? What's your GPA in high school? Is that going to be predictive of how well you do in college, right? Like, obviously, colleges care about that because they want that information from you on the front end. What else do they care about? What else do they ask on application forms?
Clubs you were in?
Clubs you were in. Okay, and what is that pointing to?
How well balanced you are.
Oh boy, I didn't get to hear that. What was that?
I said how well balanced your life is.
Okay, right. So maybe your social integration, your ability to connect. What was the other thought? Someone else said something.
Oh, I was just gonna say it tells about like your personality and how you are.
Right, right. And so first thing, break apart my example. What leads to college success? What is something you'd want to know about that particular research question?
What's the definition of success?
100%, right? Because my definition as an institution, let's put on the fact that I am president of Aquinas University, what would I say is success?
Graduation.
Graduation or retention, right? Because retention equals
Money.
money, right? Got to follow that money, I'm telling you. Okay, so I'm interested in what leads to success because that means students are staying engaged and they are returning to school for the following year, which means continued financial success for the institution. Now, I am a college professor. I'm Dr. Woltzel. How do I define success?
Good grades, maybe B's and above.
Right. I will say all A's. All of you are all going to get A's right now.
Yes.
Okay, so maybe I, as a professor, as an educator, as I'm trying to help students master the learning outcomes of this course, what I would consider success is somebody completing my course with a passing grade and, in fact, a very good grade, right? What does college success look like for a college student?
Keeping their scholarship.
Okay, so keeping scholarship, which will be, there's a lot of things in that, right? Grades are in that. What else?
Attendance.
What's that, Bree?
Attendance and just attendance and grades.
Your mic is really quiet.
I don't know how to make it louder.
Yeah. So I'm definitely, I heard grades in there, but there was something else. So let's say if it's an athletic scholarship, maintaining right status within the team or some sort of athletic performance that you're maintaining. So there can be a lot in that. What else would be considered success for a college student?
I mean, passing the class that's required. To, like, if senior year, the grades really don't matter when it's just getting the degree.
Right. Okay, so matriculating at some point, right? That's success.
Internships.
What's that, Elizabeth?
Internships.
Internships. Okay, so the application, being able to obtain a position where you get to apply what you have learned. What about, like, I don't know, college success? I think feeling successful, maybe also a sense of belonging. Would there be a social piece to that? I would think so, right? Like that you're not like, and maybe not for everyone, but for some it'd be a sense that you're like, I'm connected, I feel like I belong, this is the place for me. So there's a lot of variables, right? So if I just go, well, college success, just look at your SAT scores. I bet you some of you would go, yep, that's spot on. I scored really high and here I am killing it and crushing it in college. And others of you are like, ooh, thank goodness they didn't just take my SAT score because that was not predictive of how well I did in college, right? So whenever we think there is a pure cause and effect in the social sciences, we need to press on the brakes real fast and really tear it apart to go, what other variables are at play? Because it is almost never a direct cause to effect linear one variable to another relationship. Hardly ever, if at all. Okay. Questions about that, or is that making sense?
The only comment is Bree said attendance. That's what we couldn't hear.
Oh, attendance. Thank you, Bree. Sorry about that. Yeah, attendance, right? Like actually showing up. That's big.
That's
Cool.
a little important.
Yes. Okay. So let's define variables. So two things you need to know, and you should know this for the quiz. Okay. Dependent variable. That's the variable that you are trying to explain away. That's what you want to better understand. So college success, how do we define that? What does that look like? We're trying to measure it and figure it out. The independent variables are the variables that are expected to account for the dependent variable. That would be your SAT score, your GPA, things like that. Those are independent. Gender, socioeconomic group that you came from, right? Like what class you belong to. All of those are expected to predict in some way or impact the dependent variable. So when you look at a study or some sort of research question and you're looking at those two variables, you want to see the impact of the dependent variables on the dependent variable. Okay, but beware. Sometimes those variables can be swapped. In some cases, an independent variable in one situation can become the dependent variable in another situation. So, for instance, in a perceived stress scale, the dependent variable can compare the stress level between males and females, the majors, their jobs, or whatever, right? And the independent variable can be looking at the performance on a memory test as a function of the perceived test. Like we can swap things around depending on what is our question. So we really got to be careful as to what it is we're asking, right? So income is another big one that can kind of go in both. So maybe income is a predictor of success, right? Like somehow you're measuring like lifelong career success. So it could be an independent variable, but you can also look at income becoming a dependent variable if you're looking at majors in college, family history of being in college or not, right? And how that is predictive of income later on. So you see, so it depends on the question. So just be careful. So when I'm asking you, identify the dependent and independent variable, look at the research question that I've posed and identify it that way, or vice versa. If I'm asking you for an example, give me a research question where you identify an independent variable versus dependent variable, then make sure that you write out a sentence and you can clearly identify both. Okay.
So would we, I'm thinking about like all the variables we talked about for like being successful in college. Would we still on the test be looking at maybe one of those, like college success and attendance, for example, or do we need to include all of it, all of the?
If I asked you to come up with a research question and identify at least one independent variable and one dependent variable, you would just select one. But if I gave you a research question, a whole sentence, and I said identify any and all independent variables and dependent variables, then you need to list them all. I don't know if I'm answering your question correctly.
Yeah, I guess in terms of like in the mathematic, like like creating an equation, would we expect to have just like a, you know, independent versus dependent, or would we be including many of those variables?
Yep. So full disclosure, that would only come once we get to the logistical regression portion of this class, which is right before the holiday, which means AKA at the very end. And for the mathematical portion of that, you wouldn't be doing a whole lot towards that. Excel will do it all. So I don't know if that's helpful, but maybe that's not a worry to have.
Thank you.
Okay. The best way to describe it when we get to logistical regression is way back when. Do you guys remember how you calculated the slope of a line? And some of you are like, bringing back trauma, bringing back trauma. Right? Does that ring a bell for people? Y equals.
Yeah.
Remember that? Okay. Plus B, blah, blah, blah. Okay. So it's exactly the same. So for linear regression, when we're doing like many factors that could predict a dependent variable, imagine that same exact line, that slope equation, except you'll have multiple slope points or multiple the y-intercept, the b in there. You'll have multiple of those so that you then have a linear relationship. I'm skipping way ahead. Don't worry about it. It's all good. Okay. All right. I'm sure Elizabeth's like, sorry I asked. Okay. Okay. All right. Okay. So the dependent variable, that's always what we're trying to explain. It's the object of the research. It's the question, right? That is the thing we want to know. The independent variable usually occurs before the dependent variable, right? So we talked about temporal precedence. The independent variable would be measured and looked at prior to you measuring the dependent variable. And then the independent variable is often seen as influencing or directly or even sometimes indirectly impacting the dependent variable. So that is the relationship we're looking at. Independent variable that is impacting the dependent variable. Okay. So let's look at this example. Let's say my hypothesis is that people who attend church regularly are more likely to oppose abortion than people who do not attend church regularly. If I mention, I just dive right in. Let's go right in the tough topics. It's cool. Okay. We're not going to have a pro-con list here. This is just a hypothesis. And my hypothesis is based on a theory, let's say, that religiosity and so moral standard, are of such that if you're attending church, you probably have a higher or maybe a lower threshold for some of these social issues. So what would be a possible independent variable for that?
Religion.
Religion. So say more about that, Bree. I think that was Bree.
Well, it
or Ashley, sorry.
Depends on like what religion we're talking about.
Okay.
Because they would have a different stance on abortion.
Great point. So if my question is people who attend church regularly, first off, I need to identify which religious group I'm speaking of. So I want to get a little bit more refined in my question, if I'm hearing you correctly.
Yeah.
Yeah, no, that's perfect. Okay, so what would be something else that I would want that would be another independent variable?
Would abortion be? Just because you can look at who attends it.
Who attends abortions?
Well, yeah, like who? Okay, that came out poorly, but
I'm like, I need to rework the sentence. That's not what I meant. Keep going.
But the main point is like that abortion is something that's like been staying for a while, so you can, or like it's been around for a bit, so you can ask people who have gone if they were religious or if they were churchgoers before and so you can figure out get a good measure of like, oh, no one who goes to church does
Right.
this.
Right. Okay, so you've taken this, you've sidestepped into a new hypothesis, which is cool, which would be those who have undergone an abortion, do they have a history of religiosity? You see
Okay,
how
yeah.
that's a slightly different question. So the question here is, if you attend church regularly, what is your opinion on abortion as more of a social thing, right? Not than an actual, not whether they've undergone one or not. So
Yes.
yeah, so if I'm asking people who attend church regularly, that seems like there's an independent variable there. What do you guys think?
Yeah.
Sure there is.
All right, so I'm hearing a lot from Ashley, Kyle, and Bree. I want to hear and Elizabeth too. What do others think? What is the independent variable that I need to measure here?
Is it just attendance?
Yeah.
Okay, okay, cool.
So how would I measure that?
I mean,
Don't fill the space, Kyle. Let someone
okay,
else. I know you're saving the whole group here.
Yeah. My apologies.
No, it's cool. Someone else.
Maybe you could ask like for attendance, like you would just like take the attendance or like of like a certain church or something.
Perfect. Okay, so we need to measure church attendance in some way. So we could even make it more broad. I could pick 100 people at random and ask them, A, what's your religious affiliation, right? So maybe ask them a question, are you Christian, Catholic, Jewish, or Muslim, Buddhist, or none of the above, atheist, right? Okay, now second question could be, if you have a religious affiliation, how frequently do you attend a church or religious service, right? And then maybe I have once per year, 2 to 3 times per year, once a month, once every week, multiple times per week, some sort of category, right? And then I would want to also measure belief on abortion, right? Whether it should happen or not. And now that's where I make the connection. So the hypothesis would be those who attend church less would tend to think of abortion as a more okay construct than those who attend church more, and they would be more against that. So that's just an idea of a hypothesis here and how we could go about measuring it. Okay, so we would need to have, what's the question?
Can you hear me? Yeah.
Yeah.
People who attend church, is that not the hypothesis then? The initial one, like the people who attend church regularly are more likely to be opposed. Is that not the hypothesis? Will it change after you get all of that? Then or what?
So I was having a tiny bit of
Following the second hypothesis. Like,
I was
is
having a little
that-
bit of a hard time hearing you. I don't know if anybody else experienced some of the lag. Yeah.
I also,
So,
yeah.
Bree, I think what you're asking me, correct me if I'm wrong, is that actually the hypothesis? Am I looking at those who attend church regularly, right? Is that who I'm looking at? Well, I need to have some variability with that. So I have a comparison group. Because the idea is if those who attend church regularly are more likely to oppose those than those that do not attend church regularly, I've got 2 groups in there. So the control variable here that I have, what I'm controlling for is that hopefully all of these people hold a similar religious belief or a baseline of frequency, right? Because then my question is not religious people are more likely to oppose abortion than atheists, right? That's not the question. It talks about some sort of baseline or control variable that they attend church somewhat already, and that some attend more than others. So it's looking at frequency of attendance. Does that kind of
Okay.
clarify a little bit?
That's what I didn't
Okay.
really get it.
Okay. Yep. And then this here, we can't really make a causal claim. We can't say because they attend church more often, they oppose abortion. you see how we can't make that link? Because there might be other variables in there that play a role into that. What the hypothesis is saying is that that variable, church attendance, it has a large amount of variability as to whether they believe in it or not, support in it or not. That's the slight difference. So again, we're not looking at a causal claim. We're trying to look at the impact or the relationship between two variables, which is church attendance and the construct of abortion. Okay. One example. Yes, it looks like maybe someone has a question. Oh, it was that. Okay. Uh-oh, it's frozen again. Okay, here we go. Whoops. All right. Well, everything we talked about are right here. Church attendance and attitudes toward abortion. So somehow that's what we're measuring here. So you would ask a question about it. Okay. Other control, oh shoot, is my mic all funky again?
No.
No, okay. Other control variables would be gender, age, religious affiliation, maybe your political party identification. Those are other demographic information that we can get about the people that we are measuring within our survey, within our particular study, that are not playing an impact, right? I am not supposing that or hypothesizing that there is a relationship between political party affiliation and the support of abortion. That's not the question here for this particular study. So those would be considered control variables, meaning I'm not looking at them. They're not part of what's being evaluated. Okay. So, and we talked about, again, like, is there a causal argument? No, this is really just more looking at the relationship between the two. So we're steering clear of that because that's not what we're measuring here. Okay. So, quick note, we've looked at independent and dependent variables and how to create a hypothesis. So check and check. Switching gears slightly, how do we go about collecting data? So first, when you come up with your research question, you've then figured out which theory it falls under, what's your umbrella, and then you've created a hypothesis. You need to then decide what are the variables I'm interested in measuring, right? What are the variables that apply to my hypothesis that I need to measure in order to confirm or refute my hypothesis? And you need to then select specific cases for the research or select participants to engage in your research. So if I'm interested in college success, again, my example from earlier, and I'm looking at, you know, how am I going to measure that? Who would I be interested in measuring? Probably college students, right? Thinking that would be kind of important. And I'm probably going to be looking at different measures of success like we talked about. We talked about GPA, maybe SATs, connectedness to social groups in some fashion. Like those are going to be some of the variables I'm measuring. And then how am I going to go about measuring it? Do I measure it in the lab, right? For this one, what do you guys think? Do we need to measure that in the lab, college success?
No.
No.
No, right? I mean, that'd be weird, actually. If I'm looking at your stress response when shown horrific photos of a car crash, for instance, and I have you hooked up to a system that'll measure your sweat response, your stress response, yes, in a lab would make a lot of sense because you can't gauge that just by looking at somebody or having them fill out a survey. It's more than that. It's a physiological response. Could you do it online?
Yeah.
Totally, right? You could ask online. Now we'll talk about data collection. This is always interesting because people, college students, you folks, you are at the mercy of many a research study because it's a captive audience, not like you guys can't say no, obviously, but college students as a whole, it's a fabulous participant pool because you guys are intelligent, you're usually quite motivated, right? Oftentimes it'll be tied into a participation score in a class, right? There'll be some sort of incentive to participate in research. It's usually like if you're looking at psychology, a lot of mental health issues start right at that age group, right? Like between the 18 to 25, so it's an important age range. But we need to also be careful because if I'm going to take a sample of 100 college students, that is not necessarily representative of the entire United States, right? And what ways are college students, if I'm I mean, you guys are all adults, right? Are college students, 100 of them, the same as any other adult in the population? In what ways might they be the same or different?
Different. Talk about age.
Okay,
Having the same experiences.
right.
The same as assume that they've graduated high school or had that type of education.
Okay, great.
Say different, because we're at an age where we're going up to college in a different time than they were, and what at the ages we are now, it really shapes who you are in your future. So I'd say much
Totally.
different.
Totally, yeah. Yeah, I think there's a lot of differences. So if I say, well, the average American, so let's take this example, right? I poll 100 students at Aquinas and I ask them about how many hours per week do they engage in reading, right? Let's say they tell me 8 hours. And now I'm like, news source, flash, flash. The average American reads 8 hours per week. Wow, we are one intelligent nation that is always eager to learn and engage in more learning, right? Have I generalized the response of a small group to an entire nation in a way that is appropriate?
No.
No, right? So my generalized statement should be based on a study in West Michigan at a small Christian college, right? All of the things. The average student read for 8 hours per week, right? That would be far more important, right? And then we can compare it to how maybe a public institution in West Michigan or maybe another Christian institution on the West Coast, right? Like then we make some comparison. So all to say, the way you collect your data and who you include or exclude from your study will have an impact. So if you're doing a correlational study, meaning you're looking at what is the relationship between two variables, you're looking at the size of the relationship and the direction of the relationship. So earlier I talked about the number of hours you study and the grade you get on your test. So this would have a strong positive relationship. Now, it's not a positive relationship because studying is good. I don't know why I'm using, there it is. Right? That's not what it means. It goes back to slopes. I know you're like, oh, this is math I thought I could forget, right? Okay, so a relationship like this is a positive relationship, meaning as one variable goes up, that's an arrow, that's all, and this other one also go up. So what's an example of another positive relationship? Two variables you guys can think of that as one goes up, the other one goes up.
The more food you eat, the more full you feel.
Very good.
Can I ask a quick question?
Of course.
I'm sorry to drag us back to this example, but so just to be sure, the like church example with the abortion, that isn't an example, right? That still doesn't, even if the chart goes up like that, it still doesn't mean that?
Excellent, excellent question. No, because there we're comparing two groups. We're saying those who attend church more often tend to oppose abortion more than those who don't attend as often. So that would be more of what's called the t-test. So it's two groups. You're comparing their scores probably on the scale of acceptability of abortion and saying there's a significant difference between the two. That's what that is. This is saying there's a relationship between these two variables, and as one variable increases, the other variable also increases. Does that make sense?
Yeah, so that's not something that we would track on the chart that you're holding
Nope.
up. Okay.
Nope.
Thank you.
Yeah, a comparative group study like a t-test is not usually shown quite nicely like that. It usually would be shown with a bar graph, and it'll say this group has this score, this other group has that score. And oftentimes t-tests like that are done between men and women, so it'll split up gender. And they'll say their views on, I don't know, anything, right? What can I think of? I don't know, maybe online learning, right? Is there a difference between men and women as to how they're seeing virtual learning in schools due to COVID? And then they'll have different scores based on their some sort of survey they completed, and we'll have the score of a men versus women, and we'll see if there's a significant difference. But that's
And
a
then-
visualization of that. It's not that they're related, they're not
Okay.
co-varying.
All right, that was my main question. So it doesn't necessarily mean that, oh, my question is answered because other so many different variables come into each individual person's answer. So it's not really fair to say, well, men or women think this definitively.
Exactly. It's just saying there's a difference between them. It's saying, is there a different or no? It's a yes, no question.
Okay.
Whereas this is saying these two variables, they have a significant relationship. And in fact, every time one does this, the other one increases accordingly. Okay. So another positive relationship like this could be, yeah, so the more I lift heavy weights, the more muscles I get, right? That
And
would
those
be,
are directly correlated. So that's why we're tracking it on the, okay.
yes. Yes, Bree, great example. The more customers buy from your store, the more inventory you move, the more profits you make. That would be a great example as well. Okay, so that is called a positive relationship, not because it's necessarily good, right? Okay, let's use what would be a terrible example? Okay, let's pick, I'm not sure this is accurate, but we're just gonna, oh, go ahead, Ashley.
The more people that die in your family, the more depression you experience.
Okay, yeah. Bummer, right, totally. I was gonna say the higher the rates of school dropout, the increase in crime rates, right? Two things can go up and because there's a relationship between the two. Now, we can also have a negative relationship or a negative correlation, right? And that would look like this. It's just because the slope is negative. So it's not that the impact is negative. So that would mean as one variable goes up, the other variable goes down, right? So the more I work out, the less I weigh. That would be an example of a negative relationship. As one goes up, the other goes down. Okay? Does that make sense? So again, I just want to make sure everybody is understanding that positive and negative is not a label we're assigning it as in good or bad. It just has to do with the slope of the line and whether it's a positive slope or a negative slope. Okay. So that's a correlational analysis. An experiment would be more set up as a cause and effect. That would be more in a laboratory trying to figure out the impact of a drug in reducing a particular symptom, for instance. So then I would need to set that up in a laboratory to figure that piece out. So when you are designing your particular study, you need to be thinking through how am I going to analyze the data, and that'll shape the methodology that you take. Again, I'm skipping a little forward. You know, once you guys get into research methods, we'll dive into that a lot more, but it's good to keep that in mind for now. So that's how we collect data. Let's see here. There we go. There's different levels of measurements as well, because not every variable can be analyzed given a statistical method. There are some variables that you can't even manipulate using math because they're a nominal variable. So that would be a label or some sort of quality. So a nominal level would be political party, right? Republican, Democrat, Libertarian, Green Party, right? Like you can't fit that in with numbers because it's just a label, right? So that wouldn't quite fit. So depending on what it is you're measuring, that'll impact then your level of measurement as well. So a t-test is what I was describing, where you have two groups and you're comparing the two groups. A Pearson's R correlation, and to some level even a chi-square, we'll talk about that further this semester. That's two variables that have a relationship where they co-vary or they vary together. As one rises, the other rises, or vice versa. Linear regression, that's what I was using earlier, multiple variables that are predictive or they work as a predictive factor of the dependent variable. So what is college success? I'm looking at GPA, SAT score, SCS, all of that. That would be a linear regression. We'll talk about all these. So nominal, ordinal, and interval ratio. As I said, a nominal level is more of a label. It's qualitative in nature, not able to be measured. An ordinal level, that uses ranks and is more quantitative, but it's not meaningful. The distance between each is not meaningful, as is an interval ratio variable, where the number has a natural zero point, right? So it's on a line from 0 to multiple things. Let me give you guys examples, because I think that is just the best way to talk about that. Okay, so nominal first. Those are labels, names, or symbols that are assigned to a set of categories for the purpose of naming, labeling, and classifying. So institutional affiliation, political party, like I was saying, religion, race, those are all labels we're giving, but you can't really manipulate them and get a number out of it, right? It's just a different label. The categories are exhaustive and mutually exclusive. So Protestant and Methodist, right? So if you have both of those, that could create some confusion, because a Methodist is both Methodist and a Protestant. So they need to be mutually exclusive. So usually when you have a question that asks about religion, it'll be far more specific, where you will have, you know, Jewish, Islam, or Muslim, Buddhist, and then you'll often have Catholic and Christian as separate groups. Anyway, so it's kind of mutually exclusive in that fashion. Okay. Just for the sake of time, because it's already 4 o'clock, I feel like this class has gone just so fast today. Let's just keep on moving. So here are some other pieces of that. So gender, religion, marital status. You could probably think of others that would have that. Again, political parties, another good one that we use. You know, some sort of category. Again, you're categorizing and giving it a label, but it doesn't have a numerical value to it. Now, an ordinal level variable, that's like a nominal level, but you can rank them from low to high. Okay, so social class, for instance, upper, middle, and working class, using a Likert scale. So whenever you say, do you agree with the statement? You know, statistics is the most fun class ever. Do you agree? Strongly agree, agree, neither agree, right? Like, so you can assign a rank to them or a value, so that then you can manipulate it in some way. But the number here doesn't have as much meaning as in the ordinal. We'll talk about that in the interval ratio. The difference between a 1 and a 2, it doesn't have the same meaning as if I'm measuring temperature. The difference between temperature of like 37 versus 38, there's an actual measurement there, right? That has meaning. This has a little bit less meaning. It's just a rank you've given it to make sense of the label. Okay. This is something we'll probably do later on this semester to collect data. It's kind of a fun one, the driving anger scale. So we'll pass on that just for this moment. Okay, interval ratio, however, those are values that can be rank ordered, and all cases are expressed in the same units. All values are equally spaced. So age, for instance, right? We measure from 0, not born, until whatever age you have now. The difference between 25 and 20, right, whether you're 25 years old or 20 years old, is the same distance as between 15 and 10, the 5 years. That unit of measurement is static. It's consistent across all. Income is another one, right? The difference between 60 and 50,000, that $10,000 difference, that means the same thing if you make 300,000 or 310. So the interval remains significant. It's static across. Same with test scores, right? The difference between a 75 and a 70 is the same as a 95 and 90. Okay. The biggest thing with that is there's a natural 0 point that occurs, or that is possible. In all of those, it is possible to have gotten a 0, right? It's possible to not have been born, I guess, so age is 0. But mostly in other things that we measure, like income, test scores, there is a natural 0. So you can have the complete absence of the variable. So if you missed a test, you could have no points. If you're unemployed, you certainly could have no income. So a 0 is possible. So that is an interval ratio variable. So there's some examples here. So this is percentages as seen as an interval ratio. So this is going back to some of our examples, the sex composition of major occupational groups. So these are some examples of occupational groups. So we've got management, professional or related occupation, and this is measuring the percent of women within that occupation. So this 51%, so almost 50-50. Service occupations at 56, production, transportation, and material at 21, sales and office occupation at 61, and natural resources, construction, and maintenance occupation at 4%. So you're looking here at a percentage. The reason why an interval ratio, it's used as an interval ratio variable, I should say, is because the difference between each percentages are known across, right? It can be ranked from lowest to highest, and it can also be labeled as a majority minority, right? So if you're using a percentage, more than 50% would be a majority, less than 50% would be a minority. So you can reclassify it in some way to help give it meaning. Okay. So here are ways that we would do this if we're looking at different levels. So again, if I'm looking at a nominal measure of variable, and I'm looking at the difference or equivalence, so here's what I'm looking at. So here's the different types of education. So a nominal measurement would be graduated from public high school, graduated from private high school, and graduated from military academy. That is a nominal measurement. An ordinal measurement, again, here I'm comparing, it's one person in higher education versus another. So you've got someone with a high school diploma, someone with a college diploma, and someone with a PhD. The distance between them does not have the same meaning. You're not saying the number of years you've been in school, you're saying having the diploma or not, okay? And then if you're actually looking at an interval, it would be how much is higher or less. So this one has 8 years of education, this one has 12 years, someone has 16 years. The unit of measurement is number of years, and that is actually meaningful, right? The distance has a meaningful measurement that is the same for both. Okay, does that make sense?
It's a lot to take in, not gonna lie, but kinda.
Okay, biggest takeaway is a nominal unit of measurement is going to be some sort of label that you cannot apply math to it. If you're looking at an ordinal, think of order, like a rank order, is that maybe you can assign it a number, but it's not really meaningful one between the other. It's more of a high, medium, low, or it's going to be like the Likert scale, right? Strongly agree, neutral. You can assign those 1, 2, 3, 4, 5 and rank order them, but the number again is not meaningful. Versus a calculation like number of years you've been in college, 8 versus 12 versus 16, the difference between those numbers is meaningful because it's the same unit. Okay.
Could you give one more example of an ordinal example? So would that be like highest to lowest? So like, do you like this movie? And then somebody gave a 2, and then somebody like gave a 10.
Exactly. If you gave them a scale, right, and a lot of surveys operate on an ordinal level. If you gave them a scale and you said, how much do you like this movie? 0 to 10, 10 changed your life, right? Made you, it was amazing. 0, you hated it, walked out. There would be some meaning to the number they assigned, but is there a significant like meaning between an 8 and a 7? It's just kind of an order. Whereas if I said, give me a percentage of how much you love the movie, and you said 75 and 80, and you know, percentages you can deal with, there's more meaning behind that. It's not a rank order.
Oh, okay.
Does that kind of help?
Yes, thank you.
Okay. Your textbook has a ton of examples, and honestly, if you are still confused and you're like, I need more examples, go to the interwebs and say examples of nominal units of measurement or ordinal, and it'll spew out more than you probably ever wanted to know. But yeah. Okay. Okay, so let's look at how we can break it down. This is kind of the idea of, is a rectangle a square, is a square a rectangle, right? Looking at properties and this idea of cumulative property. So variables that can be measured at the interval ratio level can also be measured at the ordinal and nominal level. So interval ratio is kind of the most descriptive, most meaningful, And if you can measure it at that level, you can measure it at the other ones. Measurements, or variables, I should say, that are measured at the nominal or ordinal levels cannot be measured at higher levels. They stay at the lower level. And variables that can be measured at a higher level, so interval ratio is the highest, can also be measured at lower levels, but not vice versa. So that's just repeating the same thing. So if I am doing some sort of unit measurement where I'm saying percentages, just like the example I just gave, you can bring that down to an ordinal level, like a scale of 1 to 10, or you can bring it down to even, I don't know, somehow like have a label for it. But usually you cannot take them the other way around using the exact same measurement. Okay. There's an exception to that because that's how the world works. There's always exception to the rules. And that is with dichotomous variables. With dichotomous variables, there's only 2 values possible. That makes things a little harder. Since there's only 2 possible values, we can measure it at the ordinal or the interval ratio level. There's no way to get them out of order when there's only 2 options. It's kind of set, there's a set order. So again, we can collapse across values and then clump them into one of 2 categories, male or not male, employed or not employed. So again, employed or not employed, we could make that a non-dichotomous variable by saying part-time employed, full-time employed, unemployed, right? We could add a third one. But in this example, if we keep it just as a dichotomous variable, that's what it would be, kind of more binary again. Are you a parent or not a parent? Are you an undergrad or not an undergrad? Again, how could we flesh that out? Undergrad, not undergrad. What would be more categories if we wanted to add more?
First year, second year, third year, fourth year.
Perfect. Yeah, Zach, that's a great example.
Do you own a pet or do you not own a pet?
Oh yeah, that's another good question of a dichotomous. Yes or no. Sticking with the undergraduate, not undergraduate, you could say high school, undergrad, grad school, not in college, right? Like there's multiple categories there. Yep. Midwesterner, not Midwesterner, depressed, not depressed, right? So if you're trying to make it at the most basic level, just say yes, no, right? That's easier. But as we just saw, if I'm trying to understand how somebody is behaving and whether that is impacted by their education level, and my question to address that is, are you an undergraduate or not an undergraduate? I'm missing some important pieces there, right? If that's going to be my only categorization, undergrad or not, in the not undergrad, that's going to be made up of what? High school students, graduate students, high school graduates, maybe high school dropouts, right? Like there's a lot of variability in the not undergraduate category, which is why dichotomous variables tend to be a little dicey, right? You lose variability by giving yourselves only 2 options. I mean, doesn't that make sense? Just regular world. If you only have 2 options, you lose some variability because the world is usually more gray than just black-white. Does that kind of make sense?
Yeah.
Okay.
Yeah.
Okay. All right. So if the original variable, this is an exact explanation of what I just said. If you're looking at different racial groups, and you're saying, here's the dichotomized variable, white versus non-white, you lose some variability, right? Because all these folks are clumped into one group, which somehow implies that all of these folks behave in the exact same way, and that way is different than this racial group. So we need to be careful with dichotomizing variables, because I would say there's a big problem with that. Okay. This is a good little cheat sheet to keep you guys kind of understanding these different levels of measurements. So you're able to measure if something is different or equivalent in all of them. You cannot rank them if it's a nominal variable, but you can for ordinal and interval ratio. And you cannot determine a percentage increase or a determination of greater than or higher than, like the distance between the order is not meaningful unless it is an interval ratio variable. Okay. Those are the take homes. Okay. Let's talk about more variables. Discrete variables. Discrete variables have a minimum size unit of measurement that cannot be subdivided. So the number of children per family, that's got to be a whole number, right? So the minimum is 1. If you're going to have a child, that's 1. It can't be 2.5 children. So when they talk about on average in the United States, most families have 1.78 children, right? There's not a 0.7 child that exists somewhere. They're just taking averages. So if you're talking about a discrete variable, how many children do you have? It needs to be a whole number. It needs to be, that's a minimum unit of measurement. Number of cars, number of pets, number of fingers, number of pennies and dollars, all of those are discrete, minimum size, whole number variable. That's a discrete variable. As compared to a continuous variable, which is a variable that can theoretically can take on any possible numerical value in a given interval, right? So the length of this marker, right, if I measured it, could be, I don't know, I'm not a good estimator, so what is that? Let's say 6.3 inches, right? Like it does not need to be a whole number. It can be a very specific number. And in fact, as an example, an object can be 12 inches, can be 12.5 inches, or can be 12.532011 inch, right? It can take on any number on the line scale. Percentages, again, would fall in that. So that is a continuous variable. The percentage is, again, you've got a certain range and it could be 93.25, right? So you can divide it into smaller and smaller percentages. So if I looked at the biological sex composition of occupation, we've talked about this example a lot today, I could look at the percentage of women who are preschool teachers. I could look at the percentage of women who are preschool teachers and own a Honda, right? That's like taking a Venn diagram and subdividing it to look at a smaller percentage, more and more specific, okay? So that is a continuous variable. Main takeaway, discrete variable can only be a whole number. Continuous variable can take on any shape on the number line.
Okay.
Questions about that?
Nope.
Okay. All right. Measurement error. Dun, dun, dun. It feels like it needed some drama there. Okay, so let's talk about 2 things which can lead to measurement error, or 2 things we need to keep in mind to reduce measurement error. Obviously, as the name implies, that's not something you want. So first, reliability. That is a measurement that is given consistent results each time it is used, okay? So if you take an IQ test, the score should be fairly similar every time you take it. The idea is it's a construct that is reliable, that remains static throughout life, that the test itself is a reliable instrument, meaning you can test and retest and retest, and your score should be very similar, okay? So, but is a test inherently good if it is not reliable, if it is reliable, I mean? In other words, is reliability the only thing you need to have a valid test?
No.
No, that's correct, right? So if I said to you guys, I've got the best stats exam ever, it is predictive of success, and it'll just tell me how well you do in this class, and I give you this test, and it's actually a test that looks at your understanding of Greek, you guys could reliably, every single time, get the same score, right? Very bad. It would be terrible because it has nothing to do with what I'm teaching. So it would be very, very reliable, but it is not valid, which is the other point here, right? So it's still not a good test because reliability is not the whole story. In order for it to be a good measure, it needs to be both reliable and valid. Validity is the idea, it's the extent to which we measure what we actually say or intend on measuring. If I am intending on measuring your knowledge of statistics, the test cannot be about your grasp of the Greek language, right? That doesn't make any sense, right? So the question would be, for instance, does the Beck Depression Inventory, does it actually measure depression? And tests are then, that's called psychometrics, right? You're analyzing the test construction to make sure that it is actually valid. The way you would do that is if you created, they're like, oh, this is the best. There's going to be a scale that measures depression better than anything else. It's only 3 questions. It's amazing. You would give it to 100 people, let's say, your brand new test, along with 2 or 3 other tests that have already been shown to be valid measures of depression. And then you would see how well the scores lined up. So if somebody scored really, really high on depression on those 2 scales that were already like in the literature saying those are the gold standards, and then on your brand new scale, it showed like, oh, they're not depressed, there's a problem. The measure is not valid, right? There's not consistency across these measures. So a test needs to actually measure what it says it's measuring. So for instance, does the Big 5 actually measure personality traits? And historically, it's been tested enough to say, yes, it does. It hangs well with other measures of personality traits. It is consistent over time. It does actually look at those specific measures, introversion, all that you guys probably know about. So a measure may not be valid due to individual error. This is important too. So participants can actually fake responses in order to appear good. That would be called the faking good. An example of that would be if I am saying that, and this is seen in a lot of like the MMPI, I don't know how many of you are psych majors, but there's a lot of personality traits where it would seem favorable to appear better than we actually are. And so within that test, there's going to be validity questions to look at exactly that. So there are certain traits that our society has said, hey, that's a good thing, and other traits that, that's not such a good thing, right? We talked, I think, maybe in this class before about extroversion being the societally like, oh, do we think that's good? Or not lying, right? So if a scale asked, let's say this is the statement, and you have to answer true, false. I have never told a lie in my entire life. And you answered, that's true. I've never lied in my whole life. There's going to be some bells ringing, whoever is scoring that test, because chances are you've probably told a lie at one point in your life. On one of the tests, I think it's the Milan, it's a personality inventory. They have the question, I have brushed my teeth every single day of my life. True, false. If you answer true, kudos, man. But the chances of that being actually true, probably not. But as a society, we've decided you should brush your teeth every single day. That's a good thing. That's hygiene. And admitting that is kind of, it doesn't feel good. So you may try to fake good. Now, let's say you're in a prison system or in a state institution, and you're asking someone about their tendencies to be aggressive, and they're trying to get out of jail. Would they have an incentive to fake good?
Absolutely.
100%, right? And so if we're using surveys to determine if they're ready to be released back into the regular population, and there's going to be questions that are face valid, meaning I read the question and I can tell what you're actually asking me, and I can fake it a little bit one way or the other, we need to make sure we can catch that. So within tests of personality and those kinds of measures, there's always validity scales that will say, was the participant faking good? Conversely, was the participant faking bad? Now, what would be a reason why you would want to fake like you are more ill or less adjusted than you are?
Well, okay, if we're sticking to the criminal stuff, if someone's on like a trial and they're trying to be put into a mental health clinic instead of prison, you might be saying like, oh, I see purple elephants that tell me to kill people. And it's like, exactly. Oh, well, crazy.
Right. That is a perfect example. And in fact, faking bad, that's very common. So side tangent, being in a state institution, right, or like a mental state hospital where you're held because you've committed some sort of crime is far better than being in regular prison. So in fact, for about 1.5 years, that was what I did in California. And folks would fake bad all the time. So to go to the state hospital where I worked, first off, there was a pool. You could go in the pool every day. It was co-ed, meaning you could have a significant other, right? They allowed that. And anyway, I won't go down that path. There's a lot of benefit compared to prison, right? And so folks would fake all the things. Now, this is where statistics is so cool, you guys. Statistically, what is the chance that somebody has every single psychological, symptom you could think of? Statistically, what are the odds of that?
I assume fewer than 1%.
Very, very low. That someone has amnesia, they are having active hallucinations, they see and hear things, they are having active delusions, they think they're the president, Jesus, or God, whatever, that they're heavily paranoid, that they are cognitively impaired in some way. Like that, the chances of all of that, I would say, are close to zero. But the mind of somebody who doesn't grasp statistics, which is why now you guys can all commit crimes much better, right? But if you know statistics, you know that's not quite possible. So if you present with all of that, here I am looking at your symptoms, I'm like, oh, it's not possible, right? Like that's very unlikely. So now I'm gonna start wondering, what is the secondary gain, right? What do you have to gain from presenting and faking bad? Because this test is showing me you are not responding in a valid way. You are not being consistent, or you are not, what you're responding is very, very unlikely. That is why validity is so important. Okay, so see, it all tied together. My story made sense. So it's possible that there's individual error. So that's what I was explaining right here. So faking good or faking bad. But there could also be method error. It's possible that questions are just very poorly written and it's hard for the respondent to actually answer accurately. Or you could have some double barrel questions that make it so they answer one way, but you don't quite know what is it they're answering. So for instance, do you think cars should be faster and safer? Well, if I say yes, what is it that I mean, right? The question wasn't framed really well, which is why, again, on my exams, if there's ever a question that more than like over half of the class got wrong, I will assume there was a method error, that I, as the test constructor, did not formulate the question in a good way because it wasn't specific enough to show, oh, the people who studied really know this. If more than like 70% of the class got it wrong, my question was probably poorly written. So then I'll toss it. Okay, so that is reliability and validity. In order to have a good test, you need high levels of both. Okay, high validity, high reliability. Now, how do we go about analyzing our data? First off, where are our participants? So you could poll the entire population. So that is the total set of individuals, objects, or groups, or events that the researcher, you, are interested in. So if I'm interested in the entire population of college students at Aquinas, I would need to give them a survey or whatever, do the measurement for every single student. If you are collecting information from an entire population, that's called the census, which is very apropos because they're doing that currently now. So you need an answer from every single person within that given population. A sample is a subset that is selected from that population, but that subset is said to be representative of the whole. When you select that subset, that's called sampling, or you're obtaining a sample. So if I want to know how college students are performing in classes, I could just poll students in this class because you guys represent a subset of all of Aquinas. So you can then use samples to try and make inferences about population. So you take a small sample, you get the results, and you say, does this actually reflect how everybody else in the given population behaves? And we just gave that example earlier. If I'm picking 100 college students, does that reflect the entire adult population of the US? Probably not, right? So you got to be careful as to what sample you're selecting to then generalize back to the larger population. Okay. When we use descriptive statistics, that's what helps us organize and describe data that's collected from either a sample or a population. There's two ways that we do that. There's measures of central tendency, which is, well, let me just draw it out. So a measure of central tendency is how closely do they align to the center? How likely do they tend to come towards the center? All of you guys have likely seen one of these. Let's see, can you even see what I'm doing?
Parabola?
advanced math. This is maybe not a very good example, but that's meant to be a normal curve, right? So on average, this is showing, right, from one end to the other, the bulk of participants perform at this mid-ground. So usually on a test, right, if you have a test in a lower class, you will have a few people who will get A's, a few more who get B's, a ton who get C's, a few that get D's, and then very few at the tail that would get F's. That would be a nice, normally distributed test score. Okay, this is a visualization you often get for intellectual quotient, for IQ, measures of IQ. You've got the folks that are like in the superior range, very, very few, above average, here's average, below average, and cognitively impaired, right? So that is how much they tend to clump around the center or around the mean. That's a measure of central tendency, okay? Measures of variability, that has to do more with correlation. That's how does one variable vary in relation to another. So you're looking at how different they are and do they stick together as they get different. Inferential statistics instead, that's the logic and procedure that's concerned with making predictions or inferences about a population from a given analysis of a sample, okay? So again, if I am trying to figure out college success, I'm using some independent variable to infer or predict what does college success look like. That is different than describing a sample. Okay, so descriptive statistics, you're only looking at a specific sample or population and describing it, literally in the word, descriptive, right? Inferential statistic, you're trying to make some sort of a linear path or prediction or infer how a certain group will behave based on a given calculation. Okay. Make sense? Lots of terms today. Okay. So once we're done with the data analysis, what do? Well, we got to go back to the hypothesis, right? This is the whole model we're looking at in terms of the research question. So did you find support for or against your hypothesis? We never say that we prove our hypothesis correct. I think I said that earlier. We can confirm or refute or, again, support. And then if you found something you didn't expect, that is okay. Oftentimes in research, students were like, well, I had this whole idea and then I collected the data and I didn't, my hypothesis wasn't right at all. Or like it ended up, my data did not support my hypothesis. That's actually just as meaningful as if it did, because now you get to have a new platform to jump off and have some ideas as to why that is, right? What contributed to that? So evaluating our hypothesis and findings often then leads to new research questions, which is why this is a whole cycle, right? So if you find something super interesting, then maybe that fuels a new line of research they can start inquiring about. And so it just keeps on going, keeps on going. I don't think it ever really ends, right? Because we keep getting new data, new ideas. So this is, again, the same idea. So you've got this theory right here in the middle, which informs your research question, which leads to you creating a hypothesis. You collect data, you analyze it, then you reevaluate the hypothesis, which feeds back, all of these feed back into the theory, and loops back around to asking a new research question. Kind of this endless cycle. I make it, saying endless cycle sounds negative, like you're stuck forever. That's not what I mean. It's just, it's exciting actually, right? There's always something else we could do. Okay, I think we made it, gang. These are our key terms. Review them. It's 4:30, yeah, this is a long class. The independent variables, dependent variables, levels of measurement, that's gonna be big. Make sure you know what does the research process look like. Look at what is a theory, what's a unit of analysis, right? How do we go about doing that? What are variables? And that is about it. Questions for today? This is a mini class. Yes.
So in terms of what is due for next time?
Yes.
What is due for next time? I guess is what I'm talking about. Sorry.
Yeah, I'm pulling up the syllabus right now. Here it is. Hide that. Let's take a peek. Sorry, I'm scrolling. It's just a really long one. Okay, next week is quiz 1. So at the start of the class, I'm gonna have you guys all go on to Course Connect. You're gonna complete quiz 1. I'm gonna make sure that I set it up properly so it comes directly in my box, and then I'll be able to grade it. So that's what's due for next week. And then you can take a look at the readings for next week as well, which is the organization and graphic presentation of data.
Are the quizzes open note?
They are,
Okay.
because I am not next to you when I can't. Yeah. So yes.
I wanted to ask. So it was like, yes, or put the book away.
No. And in fact, I'm not going to be watching you take the test. That's weird. So I will post it on Course Connect. You will have 20 minutes to complete it. Once the 20 minutes are up, join the Zoom class, and then we'll get started.
Oh, awesome.
I will send a note to everyone at this before the start of class next week, Wednesday, to just inform everyone of that. Again, I made this announcement last week, but I'm going to say it again. If you need accommodations of any kind, please do reach out to me one-on-one. I want to make sure that everyone is set up for success and that I'm being respectful of any accommodation anyone may need. But otherwise, it's like 3 questions. It should take you 5 minutes to answer. It's not meant to be complicated.
Perfect.
There's at no point is there going to be a, oh, she really got me. I'm not trying to do a gotcha moment. It's just about capturing the big ideas.
Okay, awesome.
Well, basically, if I'm trying to set up like my little calendar here, basically for this class, we're just going to be doing like our quizzes and our labs and to keep up with the readings for both books.
That's exactly right.
Okay.
So, and not next week, the week after that, we're going to start the lab 1. We're going to do it in class together. I'm going to share my screen and have Excel up. I will walk you guys through how to do it. I will expect all of you guys to have your screens up on Excel and test out the same stats that I'm doing. And if any of you guys have questions, I'll need to find a way to give you guys permission to share your screen. But I really want to make sure that everyone is on the same page and understands how to go about and do the analysis directly in Excel. And then the lab that'll be due by the following week, you'll have to just swap one of the variables that we worked on. It'll be the same data set, just one different variable. And then you'll have to write a paper on it, which by paper, I mean copy and paste the table and write 1 to 2 sentences of interpretation. So not very long at all. In fact, all of my labs last year, not all of these have changed since last year because they were using SPSS, but most students just stayed in the computer lab for an additional like 10, 15 minutes and then completed it and just submitted it.
So which book did the PowerPoint come from today? Sorry, I'm monopolizing the questions.
Nope,
here.
it's totally fine. It's let me see the title of the book. It's not the SPSS one. The Social Statistics for a Diverse Society. It's the Frankfurt NACMEUS. I'm sure I'm butchering that. Anyway, that one.
Okay, so is that where most of our PowerPoints are going to come from then?
All, yes.
All,
Because
okay.
the other textbook is about SPSS and how to interpret information into SPSS, which we're not going to be doing this semester.
Okay, and so basically we're just going to be looking at the Frankfurt book and having our quizzes from there.
Yes.
Okay, thank you.
No problem. Any additional questions I can answer?
I'm good.
Okay. Again, I'm totally fine with everyone being unmuted if you're not in an environment that's like super loud and like at a coffee shop, like I was saying earlier. I'm fine with this. I mean, I would rather if it'd be more conversational where you guys can talk, because otherwise I'm just talking to a bunch of black boxes that don't know where this is going. So yeah, feel free to pipe up. Okay, reach out to me via text or email if you have any questions in the meantime. Otherwise, I will see you all next week.
Well, have a great day.
All right. And happy Labor Day, everyone. Enjoy the long weekend. Stay safe out there, whatever you engage in.
Yeah.
Okay. All right. Bye, guys.